Hello everyone, I am Pavithra. I am working at Dr. SNS Rajalakshmi College of Arts and Science at Department of Commerce with IT. I am going to talk about a topic about the Mercle trees. So the Mercle trees means the data structure that efficiently verifies the integrity of large sets of data. It is the binary tree where each node is a hash of some data, and each non-leaf node is the hash. It is called child nodes. So hash leaf node is called by some data, and non-leaf node is some called by child nodes. So the blockchains use Merkle trees to represent a set of transactions in a block and to efficiently verify that a specific transaction it is included in the block. So the each transaction in a block is hashed. The leaf nodes of the Merkle tree that are hashes from the transaction, and each non-leaf node is hash. It is called child nodes. So the next one, the root of the Merkle tree represents the entire set of transactions in the block. So the Merkle root is included in the block header along with other information such as the previous block hash and the current block height. So the next traversal. Traversal, a Merkle tree involves starting from the desired transaction and working up the tree to the root hash. So the path from the transaction to the Merkle tree root is called a Merkle proof. So the next one, insertion. Insertion means one root node to another root node is called inserted to where the values inserted. Next, the inserting into a Merkle tree typically involves a creating new leaf node for the data being inserted, and then repeatedly combining pairs of sibling nodes and hashing their concatenated values to create a new parent nodes until a single root node is reached. This may require reconstructing log of n parts of the tree. So the next Merkle proofs. A Merkle proof is a way to prove that a specific piece of data is included in a Merkle tree. Without revealing the entire tree, it is a small set of hashes that starts from the desired data and works. It's a way up of the tree to the root hash. By providing the Merkle proof under the root hash, it can be verified that the desired data is included in the tree without revealing any other information. The next one, how blockchains use Merkle proofs. A user wants to prove that a specific transaction is included in a particular block on the blockchain. So this is called a proof of inclusion. The naive approach is for the prover to generate a Merkle proof and submit to the verifier. Here how it works. The prover starts by locating the leaf node in the Merkle tree that corresponds to the desired transaction. In case the prover then follow the path from the leaf node to the root of the tree, collecting the hashes of the sibling nodes along the way. So the next one, the prover now has a set of hashes in case the make of Merkle proof for the transaction. That means the proven that sends the Merkle proof along with the root has been the tree and the block header to the verifier for the verification. The block header contains the aggregate signature of validators that signed to the block. So the how blockchains use the Merkle proofs, the verifier receives a Merkle proof root hash, the block of header and performs the following steps. These following steps are: the verifier recovers the public key of the aggregate signature of validators using public key recovery. Using the block header that verifies, calculates the root hash of the Merkle tree for the block. The verifier reconstructs the path from the leaf node to the root using the hashes provided in the Merkle proof. The verifier compares to the root hash from the Merkle proof to the calculated from the block header. If the root hash from the Merkle proof matches, the one of the transaction is included into the block. So that these transactions are how blockchains use the Merkle proofs. That means, thank you.